The topic is linear approximation of a function of two variables. So let's read the definition. The definition says the linear approximation L of xy of f of xy at a point AB is L of xy equal f of AB plus partial derivative x with respect to x of AB times x minus a plus partial derivative with respect to y of AB times y minus b. And sometimes instead of using L of xy, we just say z equal. And same thing on the right side. So this equation comes actually, the right side comes from the equation of the tangent plane at the point AB. That's why sometimes we call it the tangent plane. So sometimes instead of saying the linear approximation, sometimes we say tangent plane approximation. In order it's linear, I mean, you know, the equation of a tangent plane is a linear function of two variables, of course. Alright, so let's do the first example. First example says, compute the linear approximation L of xy of f of xy equal x squared y at the point 3, 1. So again, all I need is f of AB. So in this case, I need f. This is my A. This is my B is given. So I need f of 3, 1. Which is what? Plug it in to the function 3 squared times 1, which is 9. Now next thing, I need partial derivative with respect to x of 3, 1. So I need to find first fx of 3, 1. Well, before I find that one, I need to find partial, let me do it here, partial of x of any xy. And that's partial with respect to x of our function. Since y is a constant, I can take it outside. Now this is going to be 2x times y. Now partial derivative, therefore partial derivative with respect to x of 3, 1, I'm just going to plug 3 into x and 1 into y. So that's going to be 2 times 3 times 1, which is 6. Now same thing, I need to find partial derivative with respect to y of 3, 1. Now partial derivative with respect to x of xy with respect to y is partial with respect to y of x squared y. Now x squared is a constant, take it outside. Partial with respect to y of y, which is 1, so that's x squared. So I'm going to take 3 and plug it into x. So fy of 3, 1 will be equal to 3 squared, which is 9. Now the equation is easy. So now the equation will be L of xy equal linear approximation. F of AB, we already found it, f of 3, 1 is 9, plus fx of 3, 1, we already found it 6, and then x minus a is 3, plus partial derivative with respect to y of 3, 1, which is right here 9, and then y minus b, which is 1. So this is it. Now what can we do with this function of two variables? We can do question B, for example. Estimate f of 3.10.9. Why we can, and this is going to be a good approximation. Why? Because the point 3.10.9, this point is near 3, 1. So we could use z values on the tangent plane. That's what we're doing. In other words, f of 3.10.9 is almost equal to L of 3.10.9, which is, just plug in the 3.1 here, 9 plus 6, 3.1 minus 3 plus 9. My y is 0.9. 0.9 minus 1. This is just a number. 3.1, 0.9. So just use your calculator. If you use your calculator, you're supposed to get 8.7. Now for question C, they're not asking us to estimate. This time we want to find out f of 3.1, 0.9. So how do we do that? You just plug it into the original function. Is x and is y. So this is going to be equal 3.1 squared times 0.9. Again, use your calculator. Supposed to get 8.64. So what can we say about these two numbers? This is a good approximation, you can tell. 8.64 and 8.7. And that's it for this example.